Hello, and welcome back to the European Train Driver channel. Today, in this third video of our series, we embark on a fascinating journey through railway history, focusing on the pivotal transition from steam to diesel and electric locomotives. We're exploring the pivotal shift from steam power to the new era of diesel and electric locomotives after World War II, a transformation from the late 1940s to the 1970s that redefined rail transport through greater efficiency, speed, and reliability. After World War II in the late 1940s, the reign of steam locomotives, dominant since George Stephenson's rocket in 1829, began to wane primarily due to their inherent inefficiencies. With a low thermal efficiency of only 5 to 10%, these giants consumed massive amounts of coal, up to 50 tons daily from massive engines like the US Big Boy, making them highly inefficient. They also required frequent stops for water, consuming 10 to 20 tons per trip, and demanded labor-intensive maintenance crews of 20 to 30 workers for their sheds, adding to operational burdens. Post-war fuel shortages, rising labor costs, and significant air pollution from thick black smoke further accelerated their decline across Europe and beyond. In Europe, the UK phased out steam by 1968 with the last mainline run of BR Standard Class 9F No. 92220 Evening Star on January 11th, France by 1969, and West Germany by 1977, marking the end of an era. The 1930s saw the emergence of diesel-electric technology, pioneered in the US with the 1925G box cab, the first production diesel-electric locomotive boasting 300 horsepower. However, it was the 1939 EMD FT demonstrator, a 1,350 horsepower articulated unit, that truly proved transformative, leading to widespread dieselization by 1960, like the Pennsylvania Railroad fully converting by 1958. In Europe, the UK adopted diesel under the 1955 modernization plan, introducing powerful locomotives like the Class 40 with 2,000 horsepower and top speed of 90 miles per hour, and the iconic Class 55 Deltic at 3,200 horsepower reaching 100 miles per hour. Diesel locomotives offered significant advantages, boasting 30 to 40% thermal efficiency compared to steam's 5 to 10%, and lower fuel costs since diesel was 20 to 30% cheaper. They also required reduced crew sizes, often allowing for one-man operation by the 1960s, and offered multi-unit control for greater power, enabling up to 6 locomotives coupled together. With a range of 500 to 1,000 miles without needing water tenders, unlike steam, diesels provided unprecedented flexibility and operational efficiency on long hauls. While initial costs were higher and exhaust fumes posed a drawback, the economic benefits quickly made diesel the preferred choice over steam across rail networks. Parallel to the rise of diesel, the electric revolution gained momentum especially in Europe, driven by the availability of cheap hydroelectricity from the post-war period. Electric locomotives achieve an impressive 85 to 95% efficiency, drawing power directly from overhead catenary at 25 kilovolts AC or third rail systems at 750 volts DC. Benefits include instant torque for rapid acceleration like 0 to 60 miles per hour in 30 seconds, high power output such as France's BB 69,000 at 4,680 kilowatts, and top speeds reaching 125 to 200 miles per hour. Crucially, electric trains produce zero trackside emissions, offering significant environmental advantages especially when powered by clean sources like hydroelectric or nuclear energy. Europe led this charge, with Switzerland reaching 90% electrification by the 1950s, early adopters like Sweden in 1914 for mainlines, and France introducing iconic series such as the BB 12,000 in 1955 with 3,660 kilowatts. By 1970, 50% of the European network was electrified, a stark contrast to less than 10% in the US, with examples like the UK's West Coast Main Line adopting 25 kilovolts AC in the 1960s. The transition period from the 1940s to the 1970s was a fascinating era of mixed operations where different technologies coexisted on the rails. It was common to see steam, diesel, and electric trains coexisting on the same lines, creating a dynamic and sometimes chaotic railway landscape with varying operational needs. For instance, The UK's 1950s dieselization under the modernization plan saw over 2,500 diesels introduced by 1962, even as steam engines were still in regular service. France's rectification from 1950 to 1968 phased out 12,000 steam locomotives, a massive undertaking that transformed their rail infrastructure. This coexistence often led to operational challenges, as different fueling methods and maintenance requirements for steam, diesel, and electric had to be managed simultaneously. The full transition saw steam completely phased out by the late 1960s to 1970s, with diesel peaking in the 1970s before electric power continued its growth into modern times. Globally, diesel locomotive production peaked in the 1950s, with companies like EMD building over 70,000 units to meet the surging demand. Electrification mileage in Europe dramatically increased from 10,000 kilometers in 1939 to over 100,000 kilometers by 1980, showcasing rapid infrastructure expansion. This monumental transition from steam to diesel and electric power laid the groundwork for modern high-speed rail networks across the continent. Innovations like the UK's HSD in 1976 capable of 125 miles per hour as a diesel high-speed train and France's TGV in 1981 reaching over 200 miles per hour showcased the incredible potential of these new technologies. The shift brought greater efficiency, higher speeds, and improved reliability, fundamentally changing how we travel by passenger trains and transport goods by rail worldwide. Enjoyed this look into the new era of rail? Don't forget to subscribe, like, and share the European Train Driver channel for our next chapter in railway history.